Hello, welcome back. I'm Isaac Ajao. I want to uh, show to us how we can make use of Excel to perform simple analysis. Today we are going to talk about analysis of variance. Analysis of variance is used to compare means across more than two groups. Once it is two group, we go for t-testing, and that two groups minimum should be 30 observation. When it is above 30 observation, we go for z-testing. But we have more than two groups, three groups and above, we go for analysis of variance. We have one way analysis of variance. We also have two ways and factorial experiments and so on. Here we go. I want to go back to the earlier data. So still making use of this data from these two terms. I want to test whether the mean here is equal to mean here and mean here. So let me just write something on Notepad for better understanding. I'm going to write mean one. Well, the hypothesis. Should I increase? Let me increase this font. Make it 20. So mean from ADO is equal to mean from John equal to mean from Ara Mako. So can call this null hypothesis. H naught is null hypothesis. So that's us. So these are him not equal means not equal. Can write that mathematically. So this one will be H1. Now you can see the mean value is equal to this. So most time we reject. Let me write the we have more relation rule. This hypothesis statement. Then decision rule. Something must guide you. Reject H naught if P value, probability value, is greater than alpha. Alpha is level of significance. That's significance level. Most times can be 0.05. So we let that go. Having that understanding, we now go to our analysis. As I've said, go to data analysis. We're having just single factor. The single factor is just we want to see the effect of location on grade, this grade data. These are grade values. So Are we saying that the mean from Ado is equal to the mean of Ijan and that of Ramako? That's what, don't forget, that's our hypothesis. So we can establish that the mean are different, but it depends on what our result is. Now, ANOVA single factor, that factor is just location, having 3 levels, Ado, Ijan, Ramako. You can have two or more factors, but here we are considering just one. You okay that? Then you pick the input range. So in the input range, just cover the 3. Excel is very easy to use. Just pick it and select, and you have that. We are grouping by a column. You can group by rows. Very easy to group by rows. Maybe I should do that. If we close this, this can look like this. You can transpose this if you want it to look like rows. Transpose, you just select, copy, and where you want to paste it here. Come to home, under paste here, make it you have transpose. And see, transpose. When we transpose mathematics, rows become column become row. So if you transpose this, so if you want to, if your data matrix look like this, and you want to do the analysis, so when you pick data analysis and you pick that, the ANOVA single factor. So instead of picking column, you're going to pick rows here, because your data look, the way it's arranged is different. But we are not using rows, but most of our data come using columns. So let's pick columns. So delete this, just undo it. Then I've done this before, so I'll go to data analysis, single factor, column. So just select this, select this. So having selected this by columns, label in the first row, alpha 0.05, well, that's 95% confidence level. That means your setting level of significance to be 0.05. It could be above that, it could be below. It depends on the nature of data you are handling and your feed. In medicine, they set 1% of times. I mean, they set 1%, that's 0.01. This one is 5%, or even 0.1%. But when you're dealing with lives, it's 100% inspection. Now, yeah, output range. Output range, I said I prefer it by the side. So then you click OK. This is the results. Very simple. Now you can see ANOVA single factor. If you have it more than 2 factors, assuming you are not considering just location, you are considering other things like maybe distance from town, or you want to introduce another thing like rainfall, the nature of the soil, and all the rest. But here we're just considering location. You can see Ado, these are the sums, these are the averages, these are the variances of the grid. Now this is where we are going. Now look at source of variation. Source of variation, this is where variation comes from. So between groups means, how many groups do we have? We have 3 groups, 3 locations. This is sum of square, this is degree of freedom. So it's going to be k minus 1. Degree of freedom, k minus 1, that is 3 minus 1 giving us 2. So here we have 11. We have 11 rows. We have how many now? We have 30. Okay, you can see this is 30. We have 30. We have 30 observation. 10, 10, 10. Making it, so that's why we are having 27 here. So this one will be depends on the notation you want to use. The n is 30, so n minus k will give us 27. K is 3, so that's why we have 30 minus 3 of 27 here. So the total is 30, so n minus 1. Talking about degree of freedom now, n minus 1 give us 29. So this is sum of square, that's sum of square. This is mean square, this is f. Then we have this is f ratio. Dividing this one by this give us this. So this is p value generated. This is f critical. You can use each of any of these, take a decision whether to reject it, not to accept it, or to do not accept it, to accept it. Here is a 0.3. That means we are rejecting each note that says the means are equal. It means the means are not equal, because here 0.03 is quite less than 0.05. So we say here, based on this research, that the null hypothesis as stated here should be rejected. Yes, this null hypothesis that assume that, because it's an assumption, it's a hypothesis, that the mean, the grade mean from ADO is equal to that of region. So we are going to reject this and accept this. So it means they are not equal. So if we want to continue, we want to see where the mean, where the real differences are. Z does not handle that. We call it post hoc, and Docker handles it, Turkey handles it, the LSD also. This significant difference also they are there. You can use that one in SPSS. So now we can go to SPSS to do what we have just done. So we are going to copy this. Well, SPSS, by the time you copy it to SPSS, you're going to have it here. It's already here. But what we did, the analysis of variance we did in Excel cannot be done directly like that in SPSS. So we are going to use a single column. So copy this, cutting it away. Region comes under the same column with ADO. So here we're going to delete all of this. Clear. Now the variable name will change. If you want to change variable name, you go to variable view. This is no longer ADO, this is grade, because these are values of grade. So you can say grade values. Grade values. So here are the terms now, because this grade value comes from different terms. We now say we introduce values, because many of these other they don't understand language, they don't understand text that we have to code. I'm going to code now, introduce coding. Let's assign 1 to ADO. We assign 2 to region. Those are the locations. We assign 3 to Aramako. Don't forget to this 10 to yes, then 3. So can see variable automatically Excel generates that, SPSS generates that. So you can change it. Variable name here has rules. It must not start with numeric, with numbers. It must not have special character like question mark, exclamation mark. It doesn't accept spaces. Now we call this one location. Locations where the grades are collected. Locations. Here you can put space because this is what's going to appear in your results. Locations of grades. So under this, because we have used, anytime you use a code, you must interpret the meaning of the code under values. You can see values. So click on it. So one is Adó-Èkìtì. That's first location. 2 is Ijan. 3 is Aramoko Ekiti. So add, you work it. When you are through, you may have more than 3 values. Depends on how many level you have for factor. Then you okay. You can see. Come back here. You can change this to the real name of this location. Like come here, pick this. You can see this is it. You can see everything coming up. So now we can do the analysis. Go to analyze. We want to compare the means. One way ANOVA. Then grid. So the dependent variable is your grid, depending on the location. So we're very careful here, deciding what you want is a factor. No, factor should go to factor equation. So the contrast, don't need this. Then the post hoc I said the other time, to know where the real, so you may not go, you don't need to go to post hoc test, comparison test, if your each note is not rejected. If the means are equal, you don't need post hoc. So let's pick LSD. So the stocky, long count of them will give us the same result. It depends on the one you want to use. Okay, then the option. I like option because option will give you some descriptive statistics. Then if you need fixed random effect, homogeneity of want to test whether the variances are equal or not. Then we need main plot. Main plot will give us visualization of the differences. Then you continue. Okay, it when you are through, you can maximize this to see it, in a better way. So this is descriptive statistics of it. You see, Adó, Aramoko, all of these you have seen this before. This is phase effect, this is random effect. So homogeneity of variance, are they equal? The variances are not equal with this p-value. So now here, because where do we test for homogeneity of variance? It is assumed, one of the assumptions of using one way ANOVA or ANOVA generally is that we should have equality of variance. We call it homoscedasticity. When they are different, we call it heteroscedasticity. Talking about variances, equality of variances. Now here we have ANOVA graded value. You can see the ANOVA. If you still remember the results from this, is there, see ANOVA here, compare with, you can see the result here, and the result here also. They are the same. We have the same results. You can see. The only difference, so we do not reject H naught here because it is, we reject H naught here because it's less than 0.05. So it is, we are now saying that the mean from different locations are not equal. So here we want to see where they are different. So look at Adó and Ijan. Pick Ajo and Ijan. You can see it is significant. There are difference. Difference is there. Once any of this is less than 0.05, it means it's significant. Then the way SPSS is structured, those ones that are significant are asterisk. I have an asterisk here. You can see the asterisk means that there's difference, and difference is minus 13.4. Here 0.004 between Ado and Aramako. Also we have differences. Difference means Ado, okay, this Ijado has differences, but this one does not have difference. That is Ijan and Aramako. That's 0.553 and so on. So here, this is visualization of the differences. It is clearly seen here. Look at the mean of grid values. We call this one mean plots. Yes, look at Ijan. Ijan has the highest mean of grid. Ado has the least, the lowest, while Aramako follows. All these are enough to write paper. Statistics is very sweet. If you know how to do it, your paper will be rich with little descriptive statistics and little inferential statistics. Anyone picking up your paper to assess will be happy with you. Thank you very much. We meet next time.